Hello my friends, welcome to today's video. In this video we are going to talk about line spectra. So basically line spectra is something that give you information about the unknown element. For example, like fingerprints. So fingerprint is giving you exact information about the unknown person. So similarly, that line spectra of any element will give you information about that element. So, for example, there is one more example here. We have helium element. The helium element was discovered in the presence of sunlight. So, the excited atoms of that element, for example helium element, it emit radiation or spectra that we measured, and with the help of that we can tell that information about that element. So like that, so let me just here write down about electromagnetic radiation. So let me write here electromagnetic radiation. So this radiation is all around us. So there are different forms of this radiation. It have a different reason, and this radiation is we can say classified into different reasons based on its frequency, wavelength and energy. So let me just write down that for you. So electromagnetic radiation. So first here we have gamma rays. Next one after gamma rays, next you have X-rays, then UV visible, then after that visible, you have IR, infrared radiation, then microwave, and finally you have a radio wave. So this is the electromagnetic all the different forms of electromagnetic radiation. So if you move from right to left, for example if you move from radio wave to gamma rays, then gamma rays having a higher frequency. What do you mean by frequency? Frequency is, for example, if there is a 1 point, so the number of waves passing through this point in 1 second or per second is called as frequency. Yeah, so number of waves passing through a point in 1 second is called as frequency. You can, its unit is either there is a one unit called as hertz. I will just write down hertz, or per second. So gamma ray is having a higher frequency and it have also a higher energy. Energy you can measure in terms of joules. Yeah, and it have a, we say that, shorter wavelength. Yeah, so if the radiation having a higher frequency, higher energy, it means it will have a shorter wavelength. So now if I will talk about the radio waves, so the radio wave have a lower frequency, and then it have a lower energy as well, and then it have a longer wavelength. Yeah, so let me just talk about what do you mean by wavelength. So wavelength is, suppose, let me take the example of longer wavelength. So this is the wave, right? So the distance, so we called it, this point is called as crest. Yeah, and this is also called as crest. So the distance between two consecutive crest, for example, from here, from this point to this point, that distance is called as wavelength. It is denoted by symbol. The symbol is called as lambda. Yeah, it's a symbol is, we call it as a lambda. Okay, so and its unit is meter. You can measure in meter. So it have a longer wavelength, but it have a lower frequency, but as well as lower energy. Now if I will say the shorter wavelength, if frequency is very high, so frequency is very high means like this way. Here frequency is very high, but the wavelength is, you can check out here, wavelength is very short. Yeah, you can see that the distance between two crest or trough, this part is called as crest, this part is called as crest. Yes, and this is called as trough. So the distance between two consecutive, one after another crest or one after another trough, yeah, that is wavelength. So in this way, now if I will take about visible light, so visible radiation, so it have a intermediate frequency, not too high frequency and not too low frequency, so intermediate frequency having that visible radiation. It is also, we can see it, that light we can see it, it have a 7 colors, we say Vibgyor, different colors are there, 7 colors, so that one. So if I will talk about IR radiation, infrared radiation, so infrared radiation having a lower frequency as compared to visible light, it have a lower frequency as well as lower energy and longer wavelength as compared to visible light. Okay, and when these radiation, if it is falling on our skin, do we feel little warm? That's it. Now if I will talk about UV radiation, ultraviolet rays from the sunlight, so these are, we know that the ultraviolet radiations are harmful to our skin, so they have a higher, you can check out here, higher energy and higher frequency, and they have a shorter wavelength as compared to this, right? So if, and so if you move from this, from radio wave to gamma rays, so energy increases as well as frequency increases, but wavelength it decreases. So there is an inverse relationship between frequency and wavelength. So like for example, I will say that they are opposite, means if one is increasing, if frequency is increasing, then wavelength will decrease, so vice versa. Now the last point is how these frequency and wavelength are related to speed of light. So there is a equation is C is equal to, that is nu into lambda. What is nu? Nu is a frequency and this is your lambda, that is wavelength. Okay, so what is the speed of light? Speed of light is 3 into 10 raised to 8 meter per second. Here meter is the unit for wavelength and per second is the unit of frequency. So this is all about electromagnetic radiation, and little bit I just talked about line spectra. So in the next video you are going to see that absorption emission spectra. So yeah, thank you so much, hope you like, and if anything please comment. Thank you, bye.